Okay, section 5. We're going to make a switch here. In this example, we're going to look at relationships between different kinds of intersecting segments that we use and around circles, and how those relationships can be used to find missing pieces. So we're going to use secants, tangents, and chords. The first rule, the first theorem that we talk about, and again, the reteaching with practice is good about showing you the separate items, how they break them up, and how we can use that to actually play with one rule at a time before we move on to the next one. So the first 3 problems are going to all fall into this category, but let's talk about the category first. Okay, so when I have 2 chords, this has nothing to do with angles and arcs. Okay, when I have a circle, and inside that circle, I'm going to draw 2 intersecting chords. Okay, now those chords intersect in such a way that 4 pieces are formed. Okay, so A times B, or A, B, C, and D. Okay, now the rule says that those 4 pieces align in such a manner that the product of pieces on one chord equals the product of the pieces on the other. So you need to keep them together in terms of what chord they are on, okay? But we want to take the product of those pieces. So if I multiply A times B and C times D, then those products must be equal under this theorem. Okay, so if you look at number 3 now, based on that very rule, okay, they've drawn it. It looks a little bit like this. They're going to try to throw some algebraic twist at you just a little bit, but be careful about your rules and set it up correctly. You won't see a whole lot of them. Okay, so this chord has been split up into X and X. In other words, they're both equal pieces. Okay, this chord is split up into a 9 and a 4. Now, I don't need the total. Okay, for this one, I don't need the total. If I had the total, I could use it, but to find a piece. But all I want to use are the pieces. So on the first one, I have X times X. Those are the 2 pieces. I'm going to multiply those pieces together. On the other chord, I have 4 times 9. Those are its 2 pieces. Well, x times x is x squared. 4 times 9 is 36. To solve for x squared, you square root both sides. So x equals, now normally when we would take a square root of a number, we would do a plus or minus. Okay, I'm not going to do that here because these x values cannot be represented by negative numbers. So x equals 6 is my only answer. Okay, so pretty straightforward there. That's all you're being asked to do. Okay, if 2 chords intersect, they don't have to be split evenly. They can be, as you can see in this example, but they don't have to be. They might be, really, really odd-ended, as you'll see in some of the examples. But the rule still works. The product of pieces on one chord equals the product of pieces on the other. So there's number 3. Okay. Questions 4, 5, and 6. Here we want to combine 2 secant segments. So first let's talk about the rule. Let's talk about the pieces that we need for this formula, for this relationship. Okay, so I have a circle. Okay, and with this circle, I'm going to draw from a point outside the circle 2 secants. And actually, I'm just going to stop here at the edge of the circle. So these are secant segments. Okay. And again, I don't care about the angles and arcs. This time I'm looking at these pieces of segments here. Now, we have 2 pieces here. Okay. The secant segment is the whole thing from here to here. Here is secant segment 1. Here is secant segment 2. Now, each one of those is broken up into two parts. There's an internal piece, meaning inside the circle, and there's an external piece outside the circle. Same thing is true for the other one. Okay, here's what the formula says. If you take the external piece of the secant, the external segment times the secant segment, this is for, we're going to call this for number 1, it must equal the external segment times the secant segment of number 2. Okay, so those are the pieces you have to have. If they don't give you those pieces, they will give you information so that you can find them. You will not use the internal segment in the formula, only as a means to find one of the other two missing pieces. Okay, so external times secant segment, external times secant segment. Okay, so let's pick out an example of one of these. Let's use number 6. Number 6 has some is not a straightforward question. There will be a little bit of algebra that's going to work you a little bit with here, and I'll try to make sure we get an example of these as we work with them. But this is 1, and so is this. Those are the external segments. This is 2x. This is 4. Those are the internal segments. So I need the secant segments. So you take the two pieces, add them together. 2x plus 1. Take the two pieces here, add them together. You get 5. So based on the formula we just talked about, if I take the external segment times the secant segment, that must equal the external segment times the secant segment of the second one as well. Well, this one isn't too bad. Multiplying by 1, it just stays the same here. Okay, and this is 5. Subtract the 1. 2x is equal to 4. Dividing by 2. So x equals 2. And your directions are just to find the value of x, not to plug back in, so you're done. So again, don't just arbitrarily take the 4 numbers they give you, throw them in a formula, and call them good. You can't do that. That won't work. Make sure you've got the correct pieces as they're defined. And the reteaching box on the front page maybe gives another good definition for those external and secant segments and tangent segments as well. Okay? Okay, last rule. So what if now I have a secant segment with a tangent segment? Now, can you have two tangent segments? Absolutely. But here's the thing. They're always going to be equal to each other no matter how you set them up. So here's what I'm looking at for these examples. This is what a typical picture would look like. Here is a circle. Here is a tangent segment. Here is a secant segment. Okay, here is x. A tangent segment only has one value. Okay, so everything else we've had has always had 2, so we need to be able to work with that. So that's x. Let's say this is our external segment again, and then we have our secant segment. Okay, with the secant part, we work exactly as we have before. Okay, the external segment times the secant segment equals the tangent segment squared. That's how you get your second value. Okay, that's how you get your second value for these, is you take that one piece and you square it. So you got two things over here, you got two things over here. It's just this one thing squared that gives you the second value. Okay, so the tangent segment squared equals the outside piece times the whole thing. Okay, now let's look at one of those. And again, I've got my eye on number 9. Okay, let's see what happens here. So let me draw it. Secant segment. Inside I got a 4. Outside I got a 9. And then my tangent segment is 2x. So the outside piece is 9. The secant segment is 13. I need to add. And 2x, my tangent segment, squared. So 13 times 9 is, don't trust myself, I get 117. Okay, 2x squared becomes 4x squared. I'm going to divide both sides by 4. So x squared equals 117 over 4. And then I'm going to square root both sides. And I can't do anything to the top because 117, well, I am going to be able to simplify it, but this is going to become the square root of 117 over the square root of 4. The square root of 4 is going to change to a 2. The square root of 17, well, we said 117 is made up of 9 times 13. 9 is a perfect square. So if I break that up into a 9 and a 13, then this becomes 3 square root of 13 all over 2. Now, a lot of the answers that you're going to have are going to work out better. If you would probably even have used your calculator and changed that to a decimal, if I can see your steps there that you're doing that, I would probably be approving of that as well. I'd like you to be able to keep it in its exact form, but at this point in the game, I'm good with either answer. Okay, so either one of those would work. Okay, so there's the reteaching with practice. Okay, on the practice A, first of all, cross out number 13. I do not want you to do number 13, so you have 12 more problems to do. On questions 1 through 6, you do not need to fill in the blanks, because if it helps you, then use it. Absolutely. And it might. I want to be careful about that. They're using the different formulas and they're trying to set up an equation, help you set up an equation by having you fill in what's missing. Okay. And then, do the arithmetic, then the algebra involved to find the missing pieces. Let's do number 10, one more. And I think that will kind of tie up any other loose ends. So on number 10, I have 2 secant segments. So when I fill in, you got X is a secant segment, 5 is the exterior piece. I got an external piece of 6, internal of 4. So this secant segment is 10. Multiplying here, this becomes 5 times X, external times secant segment, equals external piece times secant segment. Okay, divide the 5 over. Oh, that one was too easy. So you get X equals 12. Okay. I don't know that I see anything else that's really going to cause any problem. I thought maybe you might have one where you'd have a binomial, but I don't see that happening. So I think the rest of the problems are going to, mathematically, as long as you set up the equation, will fall into categories that are a little bit easier to work with. Okay, so should be okay with that one. I hope. Review the examples that are given and the solutions to help you. That will help refresh you on what rules to use when. And then just email me if you have any questions on section 10.5.